Please open your Jupyter, and if you want to rename your file, then you would not lose it, and you're gonna remember all the time. Okay, nice. We are in week 5. Okay, last week we all together learned about NumPy. And what is NumPy, how strong is NumPy, what we can do in NumPy. About NumPy, we learned that NumPy is a library, and especially we can use array, create array, save a lot of data in our array in like 1D or 2D array, and keep using, like adding data to it, and keep like working and handling that data in any way that we want. Okay. Okay, last time we end up in the mathematical operation functions in NumPy library. Okay, we learn how to create our array, how to import a NumPy library and create that array, and do some handling data in array. And we wanted to learn some mathematical operation functions. Okay, if you remember, one time we talked about math library, and we had some mathematical operation like sum, division, subtraction, and that kind of things. What is the difference between that function in math library and like sum and subtraction function in array? In NumPy library, sorry. In function, when we use a function from NumPy library, it gives that option to us to handle a large amount of data like array and passing our array to it. But if you remember, we did a function, a square root. It was it was, I think, a square root from math, that we were passing only one value, okay, one variable into it. But in functions of NumPy library, we can pass a bunch of data as an array. Okay, let's import. Okay, import NumPy, and I start creating an array. I'm gonna name my array as A. Okay, and I will use NumPy.array. Okay. Okay. Array is a function. When I'm using a function from a library, I all the time attach the name of the library first, okay? Then dot array. How we read this line? We say array function from NumPy library. I said when we want to make it short and just not keep repeating this long word, mostly commonly coders use a short like name as it. NP is commonly using for NumPy, but you can put any name that you want there. You can put even your name and keep using your name, okay? That's depends to you. Okay, and let's create array into it. I want to make a 2D array, okay, which is list into list. Okay, I'm making braces, and I'm gonna make 2 other braces into it and put some numbers like 1, 2, 3, and whatever you want. Okay, and so I'm putting some number here. Let's create another array, okay, with different name, because we want to do some calculation on them. And let's create also this one, a 2D array. You also please do coding at the same time with me, writing a code is the only way that you can learn coding. There is no other way. Okay, add any number that you want, okay, and how many numbers that you want, it doesn't matter. 13, 14, 15. Okay, I create two arrays, A and B. In last class, we learned how to use a sum function, okay? I'm gonna do like sum, okay? And we said, okay, this is a function. Sometimes we have many functions in a library, but we don't know how to like use it. For example, for argument, we don't know how many arguments we can pass to this function. The easiest way is just like adding your variable into it. Then you can test it and learn it how to use it. Okay, I'm gonna just pass one argument to it, like A. I'm gonna just pass A and run it. Okay, it gave 21. Okay, it add up all the numbers in array A. When I put B here, okay, it adds up all numbers inside inside array B. Okay, how about like if in B I just want to like make it add just by list. I don't want to add up all numbers together, like add this list and then the other list. Okay, there is something called access. We can use access that we learned last time. Okay, this access actually telling our program to add up like horizontally or vertically. Okay, 0 was horizontally or vertically. Which one was that? I don't think horizontally. No, vertically. Yes. Okay, B axis like 23. See, 0 is vertically, okay? How it added up? It added 10 by 13, okay? And wrote as a 23. It added 14, 11, 14, get 25, 12, 15, got 27. So this axis can be only 0 or 1. If I change this 0 to 1, let's see what will happen. Okay, it added up all the numbers in the first list and wrote in the first list, okay, here, and wrote it here and put it here as a 33. And second list, and it got 42. Now I want to add my both array. Let's see, like A, B, okay. We got error. Only integer scalar arrays can be converted to a scalar index. Okay. Actually, anytime that we get this one, okay, remember a parenthesis or like or braces can fix your problem. Let's do this one. Okay, 96. It added all the numbers in array A and array B together. And how about that access? Let's see if we can use that access here too or not. Okay, I'm gonna put 0. If you don't want to keep like deleting, just go and jump to the next line. Okay, comment out this line 5 and jump to the next line and write a new line, okay? If you want to have a copy of your code and do not delete it. If I go fast, tell me, then I can wait for you, okay? Just put it in chat part. Okay, I put access Y. Let's see how it's gonna add up our numbers, okay? Shift Enter. Nice. when I put this axis 0 here, okay, it added this 1 with 10. And as 11, write it down here. 2 by this 11, and it got 13. See here. 3 with 12, and the rest. If I put 1, it added 1 with 4, put it here, 2 with 5, and put it here, okay? 3 with 6, 9, and put it there. See, so nice. Let's jump to the next function, okay? We learned about sum. We got how to use it and how many arguments we can pass it to it. We can pass 2 arguments in a sum function from Numpy library, okay? I'm gonna comment out this line and now show you like subtraction, okay? Numpy dot or np dot subtract. Subtract is a function that open close parentheses. Anytime that our word or anything that we use is a function, do not forget that a close open parenthesis comes next to it, okay? And let's see how many arguments we can pass to this function. I'm gonna put a, okay. Invalid number of argument. It quickly actually telling us that we cannot pass 1 argument into it, okay? I'm gonna add another argument. All the time we separate this argument with a comma, okay? I'm gonna add also my b. I have an array a, I have b, I'm gonna add b2. Let's see what's gonna happen here. Shift, enter. Okay, it came and subtract numbers from a array with numbers from b array, 1 by 1, okay? What if I put like b first and then a? Let's run this one. Shift enter. Okay, now like 10 minus 1, 11 minus 2, it goes something like that. Let's see, do we have, it is working like the sum function. Can I add access to it and telling, oh, just like do subtraction in vertically or horizontally? So we can just try. Anything that we don't know, we're gonna just try and figure it out by ourselves, okay? This is a way that you can learn coding. Access equal 0. Okay, invalid number of arguments. See, it doesn't accept that actually. Yep. Invalid. This way you can consider as a 2. Okay. Nope, it does not recognize. It does not recognize that access. Okay, this was subtraction that we did. When we want to subtract like 1 by 1, do you remember that indexing number? You could just write something like this, okay? Like subtract like 5. I want to subtract 5 from 14, okay? This was like a index number like 1, and also this part, this is index in the column, it is 0, 1, index number 1, and b 14 is also 1, 1. Okay, 9. Cool. See, if we want to like subtract 1 by 1, we use this indexing number. This indexing number helps us to reach out to each element or value inside the array list or anything that we have. Do you remember all that? So cool, okay? I'm gonna comment out this one, and let's go to the next function, and let's see what we have for the next function. The next function is division, okay? np.divide, okay? If we want to divide variables, we're gonna first try just passing one array or one argument to it and see how it's gonna work. Shift enter. Invalid number of argument. Okay, how about also adding two? Yep. We should pass also two argument to divide function. Okay, but sum we could pass also one and also two, but divide is not like sum. We can just passing two argument. Okay, one array and the other array. Okay, divided, like it divides 1 over 10, 2 over 11, 3 over 12, something here, 4 over 13 as this one. Okay. If we want to check this one also gonna work it like sum or not, we can like test it, but I don't think this one also work. See if we can just test it. Okay, access equals 0. Does it works like this or not? Okay, invalid number of argument, it doesn't accept. Okay, we can just use it like this, dividing one array with another array. That's it. Okay, the next function that we have is multiplication. Multiplication should be exactly the same. np multiply. Let's pass one argument first and see what will happen. Okay, shift enter. Invalid number of argument. Okay, I'm adding second argument or variable into it. Okay, let's run this one. Shift enter. Yes, so it came up 1 times 10 make 10, 2 times 11 makes 22, 3 times 12 make 36. Okay, nice. Let's see if this one also accepts that access or not. We're gonna test it out to figure out if our access will help and can be like multiply like by list or not. Invalid number of argument. Okay, it does not recognize this access. Okay, I'm gonna comment out this one too. Okay, this was some of mathematical operations. So let's see what else we have. We have more mathematical operations. The other mathematical operation that we have is a square root. Okay, that square root one time we had in math, but I explained that in math we only pass one value or variable to it, but here we pass all the like array into our function. Okay, let's create this square root function and passing just one array into it. Shift enter to run our code. Okay, a square root of 1 is 1, a square root of 2, a square root of 3. Okay, nice. Let's see if I can pass two arguments into it or not. I don't think so, but let's see. Yep, we cannot. Okay, we cannot pass two arguments into a square root function. Just one will work. Okay, if I like write b, we want a square root of b. Yes, see. I'm gonna comment out this one. If you want to have a like description next to it, you can comment and write your description in front of your line here. Okay, we have exponential function. That exponential function actually in math actually we use that power function to the power. Yeah, exponential is say the constant value of e to the power of all value in the array. Okay, let's see how this one works. I said np dot xp a, passing a argument into it. Okay, it comes here, and what it say? It say constant value e to the power of 1. Okay, constant value e to the power of 2, constant value of e to the power of 3. It work like this. And the other functions that we have, like logarithm, sine, cosine, and that kind of things, okay? We can only pass one variable, one value into that functions also, okay? These are kind of math functions that we have in our like Numpy library. Let's do like look. So here I'm doing this log function. Yep, nicely printed out the result. See? How about cosine? I'm putting cosine. It printed out all the values for me. See all the results so nicely. So these were some example of math function that we had in our Numpy library. Some other useful function is some statics function that we need to use. Sometimes we need to use, okay? Let's learn some statics function also. Some static function is like minimum, maximum, or average, that kind of things. Here, let's start from here and writing some statistic functions of Numpy library. Okay, the first, so see I have this 2 array. I just gonna call that function and passing my array or variables into that function. So easy, okay? Like np dot minimum, give me the minimum number in a variable. What is the minimum number? See, it is 1. What is the minimum number in a variable or array b? It's 10. And maximum also works similarly. Max. You learn actually this max function, but this max function now is out of a Numpy library. Like, what is the maximum number in B is 15. The maximum number in A is like 6. Okay. How about I want to have the average of my A array, or the all numbers that I have inside my A array. I want to have the average, okay, which is mean actually. I'm gonna comment out this one and write np dot mean. Mean gives the average number of my array. My array is A. Let's run this one. Shift enter. 3.5. Okay, 3.5 is the average number of all my number values that I have in A. How about B? Okay, B is 12.5, the average. Okay, and we have also median. Median gives the middle number. I think in this one it should be same. Median is same as mean here. Yep. Because my number is just like they're added by 1, 10, 11, 12. Okay, in order. They're in order. Then median here is similar to mean. We have correlation coefficient also, some of the static function that we have. Let's write that coefficient, correlation coefficient, okay? We write this function like this, correlation coefficient, okay, of B. Correlation coefficient tell us that how strongly they related to each other. Okay, they related to each other with value 1, because they are different with just one value, 10, 11, 12. Okay, this was the correlation coefficient of our number. And also we have a standard deviation function. Okay, we have like a list of numbers and values. We want to know the like a standard deviation of that list and numbers that we have. Okay, STD is a standard deviation, okay, function. I'm passing a argument into it and shift enter. Okay, this is my standard deviation of all numbers inside array A. If I put B, it's gonna give another number. Okay. This was actually our Numpy library, and in Numpy library we said it's really useful to use Numpy array to save all your data. Okay, we learned that list. Probably you're gonna say, okay, list is easier, it doesn't need to add another library or use another library. But remember, if you want to handle your data, array is one of the really cool things that you can have a lot of data, save a lot of data into it, and work with that one like so easily. One of the reasons that all programmers use this NumPy array in NumPy library to save their data is it takes really a small amount of memory. But when you use something like list, so it's easy just adding your like data to list and use it, but it takes a lot of memory in your device. And that's the main reason that they want to use a NumPy array. Let's check the memory size that our NumPy array takes compare with that list. Okay, I'm gonna create a list and NumPy array at the same size. Okay, with same like with same elements inside, and compare that and compare the size of them inside the memory. Okay, we import NumPy as np. Okay, I'm gonna create my array. I'm gonna call it my array. Okay, here we want to test I'm gonna comment out testing memory size. Okay, my array equal np. We had arrange. Do you remember that arrange? I explained about this arrange function to you. This arrange function just create your array, and any number that you put here, it creates a size of numbers that you put it here, and keep adding numbers, a range of number from 0 to 1000 to that array. Okay, now I create array. My array has 1000 placeholder, and all that block or placeholder fill it out from 0 to 1000. Okay, I'm gonna create similar list. I'm gonna call it my list. My list equal we have similar things to inside Python, which is range. Do you remember range? Range was creating our list, okay? And if I put 1000, this range also create a list which has 1000 placeholder or blocks, and all that placeholders fill it out from 0 to 1000. Okay, now they are exactly similar. How I can check the memory size? We want to print the memory size. I'm gonna say this is memory size of array. Okay, and here I'm gonna say my array dot size. Okay, dot size times my array dot item size. Okay, dot item size. I'm gonna explain you why I wrote like that. Here we need to do something. We need to print the memory size of this list. Okay, I'm gonna say this is memory size of list. Okay, here for printing out memory size of list, we use system. System is a library inside Python, okay? SYS dot get size of my list. Yes, times length of my list. Okay. We need to import the system. I'm gonna come here and import system, okay, like this. The reason that I wrote it like here, my array size times my array item size. In array, first we go and create a placeholder, an empty placeholder, and mention the size. First I went and create 10,000 placeholder then, and then I fill it out, okay? You may create that placeholder empty and just added 2 items into it. So first I need to consider the size of whole my array that I empty that I created, and then item size that I passed to my array. Okay, for the list also same thing, get size of my list and the length of my list. Okay, now let's run it. Okay, nice. See, this is memory size of array, which is 4000, and this is memory size of list, which is 48,000. It's almost 12 times more than array. So we exactly create same list and array, but the list is 12 times larger than array. See, there is a huge difference. Because of that, we keep using array. And if you ask, what is the reason why such kind of things happen while we just save similar data in both of them? When we save data in array, actually it creates one level memory. It directly puts whatever you have, your item, into that placeholder. And anytime you're looking for that, it just points at, like a pointer, point to that index number and place that data is there. But it's not similar things in list, okay? In list, it doesn't save your items, your data in that placeholder. What placeholder, list of placeholder, keep and hold, there is an address. The address where your data, put it in your memory, in your RAM, your data saved, and the address of that place saved in the placeholder of list. And each time that you pointed, you're looking for that one, it point to that address, and then that address mention where and go where your data saved. And also this is the reason that when we work with array, it is faster. When you want to reach to a number, to a data inside your array, it give back and return data so faster than list. Okay. And now let's go to the pandas. Pandas is one of the most coolest library of Python. Okay, my favorite library in Python. What is pandas? Panda is a Python library which created in 2015. It is open source, free, and I think that's the main tool for data analysis that we use. Okay. What kind of data we can use in pandas? Something like tabular data, arbitrary matrix, and time series data. That kind of data that we all the time commonly use in pandas, like Excel. Like Excel sheets is a kind of tabular data or arbitrary matrix, okay? It can be one-dimensional, two-dimensional, even three-dimensional data. About three-dimensional data, I don't know because I never saw three-dimensional data, but we commonly use that two-dimensional data in pandas, okay? What we can do with pandas, I'm gonna give you one example, okay? So Panda is the main tool for data analysis. Any kind of data analysis like taking average, like a standard deviation and that kind of things, or it has a nice function. It has a lot of statics function. For example, just think, we have an Excel sheet. That Excel sheet has like 1 million rows and columns. One features of pandas. In Panda, we can handle huge amount of data. It doesn't matter. It can be really, really huge, but still we can handle that all data in Panda, okay? Just think we have Excel sheet is 1 million rows and columns, and it's about employee of United States, all employees, and they're like engineers, doctor. We have for like columns, we have carrier, they're like employee ID, name, age, gender, if they're female, male, their address, phone number, like their city and state, like from California or wherever I am. I'm coming and telling my program in pandas, by pandas, okay, return or give like this. Give the average salary of male engineers in California. And it can just print out that data for me and return quickly with one line code. It can return quickly that data to me. And we can create a graph. How about that graph and plot it with a matplotlib? Matplotlib is a library that all the time we're using with pandas. They look like sister brother. Okay, and after that data, we can save that data. We can put like graphs and show it like chart and bars and anything we can do and show it and display it in that kind of graphical displays. Okay. Now let's go and learn how to use Pandas library. Okay. Panda can be the most important lecture that we have during this class, during this course. If you learn pandas well, which is so easy, you will be data scientists. Okay, Pandas Library. Okay, have we import? We import exactly like other libraries that we keep importing. We just write import pandas. That's it, and I start using that. To make it shorter, as I told you, you can put something like a small. PD is something that commonly coders use to make pandas short, okay? We're gonna use PD. You can put other things also. I'm gonna use this PD. You may commonly see this PD, okay? I'm gonna create a list, okay, first. And I want to show you the data frame that we commonly use in pandas, the shape of data that we commonly use in pandas, okay, functions. Let's create a list, a 2D list. I can name it like data, okay, my data, or whatever name that you want, you can just put it. Let's create a 2D list, okay? The 2D list has the list inside the list, okay? And I'm gonna put some numbers inside this, 1, 2, 3, 4. And here also some number 5, 6, 7, 8. Now I want to display this data as a data frame, like a pandas data frame, okay? These are just so simple and like easy functions before handling all that Excel sheets and other data, okay? This is so small. I just want to explain that details to you. Let's create a variable, put a name like file. Okay, I'm gonna call this one file and say pd dot data frame. I'm calling data frame function. I'm calling this data frame function from PD or pandas library, okay? And equal it, put a name for that, which is file, okay? And pass what I can pass to this data frame, my data, whatever data that I have, okay? Data. And then come and print out this file. I want to see how this file will be displayed here, okay? See, this was my data, okay? This is 1 to 4 and 5 to 8 is my data. And it printed out as a row and column, okay? It all the time keep showing your data as a row and column with index numbers, because when we play and we want to access to our data, like I told you, okay, just print out column 1 or some data from column 1 and from column 1 to column 5, something like that, okay? We keep like exporting our data like that. Because of this, pandas all the time showing our data with these index numbers, okay? If let's give another example, like that dictionaries. Do you remember dictionaries that we learned how to create a dictionary? So I'm gonna create a dictionary. I call it data1. Okay, let's call it data1 equal a dictionary. Dictionary was curly bracket. Okay, like I can have name here. I want to create a dictionary of name. Do you remember this one? Then we put whatever name that we have inside braces. Hope you all remember this kind of things, and just start putting some numbers to it, some names to it, okay? And I'm gonna create another key. inside my dictionary. Do you remember that dictionary keys, values? So, for example, each name or each person has a social security number, okay? I'm gonna put that social security numbers. That social security numbers can be anything. And then I want to now print out the data frame of this data that I have. Okay, I'm gonna do same thing. File one equal pd dot data frame and passing my data one into it. Okay, and then come down and let's print our file one. Okay, see here it printed out. This is the part of print out our data as a data frame. So in the column bar, okay, we have name and we have social security numbers, and in the name column we have all these names and social securities, and here is the indexing number or rows. Okay, this is exactly like Excel file. Yeah, now let's go to our Excel file. I wanted one thing that wanted to explain here. Do you remember these columns? Actually, that Excel, the header of columns in our Excel sheets come and fit instead our index number. Instead going and calling that index number when I want to reach to column 10, instead calling and put it inside the braces 10, I just put the name of that column. That's the way that we can work with this data frame in Pandas, okay? But for rows, we can just call this numbers. This is actually the way also in Excel we do. Yeah. Okay, here I create a so simple Excel sheets for you. Now we're gonna learn how to work with these Excel sheets, okay? I just, these numbers and data is wrong because I just randomly added numbers to it, okay? We have a data sheet, which is there's num, there is a 1, 2, 3, 4, 5, 6 columns. Name, gender, age, salary, experience, and career about employees, okay? And there's like 25, okay? 25 employee we have. And they have different salary, they have different range of age, they have a different gender and experiences, okay? We want to handle and work with these data sheets. How we can handle our data here, okay? Let's see. How import a data sheet into our Python and start working with that data. We imported our pandas, yeah, as PD, okay. Let's create a variable, okay. First, I'm gonna tell this one. I want to read and open my Excel file. How I can read that one? From Panda or this PD dot, okay, that means from Pandas library, call read function, read underscore Excel. This is the extension of my file, the type of my file that I have. If your type of file is different, then you put different, that extension of your file here, okay? And then open close parentheses. What inside the parentheses we put? Do you remember that modes? R, W, that mean write, R mean read. We put them at the beginning, okay? Just put that R, and inside this quote mark, I put the name, the complete name of my Python, of my Excel file, or what kind of, any kind of file that I have, okay? The full names, like Python practice, Python practice 1.x. let's first print. I want to first print out and see if I, okay, see, to print it out, I can hold this line inside my print parentheses, or otherwise, like creating to make it short, just equal this a variable, okay, like my file data, whatever, okay, I'm gonna call it my file equal. This way I make it shorter. Instead putting whole this line inside this parenthesis, I just put this one inside my parenthesis and print it out, okay? Let's run it. File not found error. Anytime you receive this error, the other things that you do, go and put the directory of your file here, okay? That means this program couldn't find your file, but my file is here, I see it, okay? It's not something that file doesn't exist. My file is, okay. Let's go and type on, I want to just like having that. Copy full path, okay? I copy this full path here, and let's put that path here, see? Okay, I'm putting my file path here, see? And let's run this one. Oh, nicely, I have now access to all data that I had in my function, in my Excel sheet, see? For example, I want to just now print out the salaries or the average of my salaries. So easily I can do this, okay? I can say I'm telling, do you remember how we were handling all column, row in array and list? It's exactly the same thing, nothing more. This is exactly our array. Just consider this one as an array that we had, okay? Like what was the name of my file? Okay, my file, what? Like gave me age. See, now I just printed out all age, so I can just tell, okay, give the average age and that kind of things. So before our class, like before getting 4 p.m., I want to explain about the project that this weekend we have, and then we will continue the rest of these lectures next week. So remember that this is the main and really important part of our lectures for data analysis, okay? Therefore, try to join next class, absolutely. Do you have any question before I explaining about our project? If you have any question, please ask me now. Otherwise, I can go and explain a little bit about the project that we have. Let me stop sharing. And okay, where was my, okay, about project that we have this weekend. This weekend, you're gonna create a game and use NumPy array to create that game. Your game needs 2 players, okay? First, you're gonna code, the story of game is like this. One of player gonna enter 3 numbers, and the second player have 5 chances to guess what was that numbers, okay? That the first person entered. Do you remember how to hide the result? One time I showed you in the first game that we had. What you need to create a NumPy array and use, let me show you my, okay. Share this, well, this is so small. Okay. Use this NumPy line space function. Do you remember what was this function doing? The first number was the starting number. This one actually creates array, okay? A starting, A is a starting, B is end number, and C was interval. You need to ask your player, your first player, enter A, B, C, create a variable A, B, C, and plug that one inside this. This automatically create your array. Create an array which the beginning number is like A and the end number is B with an interval. Then use that like all functions that we learn. You can use loop, for loop, while loop, if else statement like this. Ask your second player, okay, guess, enter number A, and it's supposed to enter like one number or just guessing one number, and your program needs to go search in your array and check if whatever your second player enter exists in your array or not. Okay, you're gonna create that for loop for I in like the interval of your array if whatever your like input that your user entered is equal one of the like value inside your array, print out, yes, you guess correct number, this number exists in my array. If not, say no, try again, and give another option for your like your user to enter another number. Okay, and keep going 5 times. That's one. Give 5 chance to your second player to guess. Did you get it? How to go and do that? For I will put in the end of this weekend, I will put one simple code, but you try by yourself first, okay? First try by yourself, see if you can create something like this. You're gonna check looking inside your array if this number that your second player enter is similar, you have same value or not. And after 5 chance, when that 5 chance done, give a hint to your player. Ask, do you need a hint? If said yes, give one number. Say, print out A. Say the minimum number in array is A. Print out A. Then your player can understand what is the minimum number and guess other than that one. Okay, or what is the maximum number in your array. And after that, again, call that your loop and give 5 chance. Let's guess your players if that number exists in your array or not. With for loop, you can check it. With while loop, you can check it. Or I don't know if also say that you can do it or not. Anyone thinks differently, okay? And check if that number is equal to any value in your arrays or not. And after 5 chance gone, give another hint. Say maximum number is this. And let's guess. That's depend to you how you want to design it, okay? You can give like 10 chance. You can just give like 3 chance. That's depend all to you. And if couldn't, then it is a loser. It's a game over. If guess, then it's a winner, okay? Some game like this. I'm gonna put, so you have all these slides. If you didn't understand the game, I can explain it more, like email me, okay? And ask me. I will put all, you have access to all these slides. And please ask me if you have any other question. Otherwise, I see you all Tuesday.